Hello everyone, welcome to Infinity Learn by Sri Chaitanya. In today's session, we'll discuss MPL Physics Unit Test 6 paper. So let's start with question number 1. In the electric field of a point charge Q, a certain charge is carried from point A to B, C, D and E. The work done is. So in this case, all these points are on the equipotential surface if you look at it, because all these points are equidistant from the charge Q, right? So potential due to charge Q at A, B, C, D, E will be what? KQ upon R, right? So there's no potential difference between AB, AC, AD and AE, right? So work done, which is equals to Q delta V, will be 0 along any one of the paths. So correct answer is option 3. Next is question number 2. The work done in bringing a 20 coulomb charge from a point A to B for a distance 0.2 meter is 2 joules. The potential difference between the 2 points will be. So Q delta V is equals to work done. So over here delta V will be work done upon Q, which is equals to 2 upon 20, which is 0.1 volt. So correct answer is option 3. Next is question number 3. Two plates are at potentials minus 10 volt and plus 30 volt. If the separation between the plates is 2 centimeter, the electric field between them is. So electric field is delta V upon D. Okay, so delta V is the potential difference, that is 30 minus of minus 10 divided by D is 2 into 10 power minus 2 meter, right? So this is 40 into 100 divided by 2 and that is equals to 2000 volts per meter, which is option 1. Question number 4. A spherical body of radius 3 centimeter having a charge 48 nanocoulomb is joined by metal wire to an uncharged spherical body of radius 5 centimeter. The charges in the equilibrium on the two bodies respectively are. So Q1 is given as R1 into Q divided by R1 plus R2 and Q2 is given as R2 into Q divided by R1 plus R2, right? So R1 is 3 into 48 divided by R1 plus R2 is 8. So this will be 18 nanocoulomb and this will be 5 into 48 divided by 8. So this will be 30 nanocoulomb. So charges on these two bodies in equilibrium is 18 and 30 nanocoulomb respectively, which is option 4. Question number 5. You are given 32 capacitors, each having capacity 4 microfarad. How do you connect all of them to prepare a composite capacity having capacitance 8 microfarad? So what we'll do is we'll connect 4 capacitors in series. So equivalent of this series will be 4 upon 4, that is 1 microfarad. Now this 1 microfarads are connected in parallel. 8 groups of 4 condensers in series are connected in parallel, right? So this will give you what? Total equivalent capacity of 1 plus 1 plus 1 up to 1 8 times. So this will be 8 microfarad. So correct answer over here is option 3. Question number 6. 4 condensers, each of capacity 4 microfarad, are connected as shown in the figure. If Vp minus Vq is 15 volt, the energy stored in the system is. So energy stored is half CV squared. Find the C equivalent of this one, which is 4 and 4 are in parallel. So it will be 8 microfarad. Now 4, 8 and 4 are connected in series between P and Q, right? So equivalent capacitance will be 1 upon 4 plus 1 upon 8 plus 1 upon 4, that is 1 upon C equivalent. So it will be 8, 2 plus 1 plus 2. So this is 5 upon 8, which is 1 upon C. So C will be 8 upon 5 microfarad. Right, so after putting all these values in half CV square, you'll get the value of energy stored in CGS unit as 1800 ergs, right? So what you can do is, after getting the value of half CV square in joules, you can convert it into erg to get the total value as 1800 ergs. So correct answer is option 2. Next is question number 7. The internal resistance of a 2.1 volt cell which gives a current of 0.2 ampere through a resistance of 10 ohm is. Okay. So I, which is E upon R plus small r, in this case, so I is 0.2 into capital R, which is 10, plus small r is unknown, and we have 2.1 as E, right? So this is 2 plus 0.2 R is equals to 2.1. So 0.2 R will be 0.1 and R will be 0.1 divided by 0.2, which is equals to 1 by 2, and that is 0.5 ohm. So correct answer is option 4. Next is question number 8. A wire of resistance 4 ohm is stretched to twice its original length. So resistance of stretched wire would be, so new resistance R dash will be N square R, which is 2 square into 4, that is 16 ohm. So correct answer is option 2. Next is question number 9. Kirchhoff's first law is summation I is equals to 0 at a junction is based on the law of conservation of charge. So correct answer is option 1. Next is question number 10. In the circuit shown in figure, the rate of heat produced in the 5 ohm resistor is 20 joule per second. Then, which of the following options are correct? So for 5 ohm, I square R is equals to 20. So I square will be 20 upon 5, which is 4. So I will be 2 ampere. So current in this is 2 ampere. This complete is 10 ohm, right? So let's say current in this one is I, and this 2, 10 and 5 are in parallel, right? So we know that for parallel, I upon 2 is equals to 5 upon 10, right? So I will be 1 ampere. So current in this one will be 1 ampere. I1 upon I2 is equals to R2 upon R1. So current through the 6 ohm resistor is 1 ampere. So this is true. Current through 5 ohm is 2 ampere, which is true. The rate of heat produced in 4 ohm is 4 joule per second. So yeah, it is I square into R. So it is 1 square into 4, that is equals to 4 joules per second. So all A, B, C are true. That is why option 4 is correct. Next is question number 11. The magnetic moment of a short magnet is 8 ampere meter square. What is the magnetic induction at a point 20 centimeter away on its equatorial line from its midpoint? Right. So over here, we know that it is mu naught upon 4 pi m upon r cube. So it is 10 power minus 7. M is 8 divided by r cube is 0.2 whole cube. So after solving this one, you will get your answer as 10 power minus 4 Weber per meter square, which is option 1. Question number 12. The strength of the magnetic field in which the magnet of a vibration magnetometer is oscillating is increased to 4 times its original value. The frequency of oscillation would then become, so frequency of oscillation is directly proportional to under root B. So if we are increasing the strength of the magnetic field by 4 times, the frequency of oscillation will increase by 2 times. So correct answer is option 1. Question number 13. The magnetic susceptibility is negative for. So it is negative for diatomic material only. Dimagnetic materials only. Right. So correct answer is option 3. Question number 14. Two magnets of each magnetic moment M and M are placed to right angles to each other so as to form a cross. The magnetic moment of the system will be. So magnetic moment of the system will be under root of m1 square plus m2 square, which is equals to under root of m square plus m square, and this will give you under root 2m. So correct answer is option 2. Question number 15. An alpha particle and a proton travel with same velocity in a magnetic field perpendicular to the direction of their velocities. Find the ratio of their radii of their circular path. Okay, so R is equals to mv upon qb. So for alpha particle, it is 4m because for proton and alpha, if mass of the proton is m, mass of the alpha particle is 4m. If charge on proton is q, then charge on alpha particle is 2q. So for alpha, it is 4mv divided by 2q into b, which is 2mv divided by qb. For proton, it will be mv upon qb. So if you take the ratio, the answer will be 2:1, which is option 3. Question number 16. What is the magnitude of magnetic force per unit length of a conducting wire carrying current of 8 ampere and making an angle of 30 degree with the direction of uniform magnetic field of 0.15 Tesla? So force is ILB sine theta. So over here, force per unit length will be IB sine theta. So it will be 8 into B is 0.15 into sine 30 degree, which is 1 by 2. So correct answer will be 0.6 Newton per meter, which is option 1. Question number 17. An infinite speed conductor carrying current 2I is split into a loop of radius r as shown in the figure. The magnetic field at the center of the coil is. So due to this and this, there will be no magnetic field at the center of the coil because point is on the axis of the wire. Now due to the upper half semicircle, the direction of magnetic field is into the plane. Whereas due to the lower part, it is out of the plane. So this and this both are equal and opposite. So they will cancel each other. Right. So net magnetic field will be option 4, which is 0. Question number 18. Magnetic field due to 0.1 ampere current flowing through a circular coil of radius 0.1 meter and 1000 turns at the center of the coil is. So it is mu naught n I upon 2r, which is 4 pi into 10 power minus 7, n is 1,000, I is 0.1 divided by 2 into r is 0.1. So after solving this one, the answer will be 6.28 into 10 power minus 4 Tesla, which is option 3. Question number 19. In a medium in which a transverse progressive wave traveling, the phase difference between the points with a separation of 1.25 centimeter is pi by 4. If the frequency of the wave is 1000 hertz, the velocity in the medium is, so phase difference is equals to 2 pi by lambda into path difference, which is 1.25 into 10 power minus 2 meter. So pi cancel, so lambda will be 8 into 1.25 into 10 power minus 2, which is equals to 0.1 meter. So velocity is lambda into frequency. Lambda is 0.1, frequency is 1,000, so it will be 100 meter per second, which is option 3. Question number 20. The displacement of a particle in a medium can be expressed as this equation, where t is in second and x is in meter. The speed of the wave is. So it is omega by k. So omega is 100. This is omega t plus kx plus pi, right? So omega is 100, k is 20, so it will be 5 meter per second, which is option 2. Question number 21. The equation of a stationary wave is given by this. We need to find the separation between two consecutive antinodes. So this term, if we compare this equation with the 2a sine kx into cos omega t, then k will be pi by 3, which is equals to 2 pi by lambda. So lambda will be 6 centimeter and the distance between two consecutive antinodes is lambda by 2. So it will be 6 divided by 2, that is 3 centimeter. So correct answer is option 1. Next is question number 22. We have two equations and these are two sound waves, and when sounded together we need to find the beat frequency produced. So for this one, this is omega 1 and this is omega 2, right? So basically this is 2 pi f1, which is 484 pi. So f1 will be 242 and 2 pi f2 is 480 pi. So f2 will be 240, right? So beat frequency is f1 minus f2, which is 242 minus 240, and that is equals to 2. So correct answer is option 3. Next question is question number 23. A listener moved towards stationary source with a constant speed and crosses him, then correct the graph between apparent frequency with time t is. So when the listener is moving towards the source, the apparent frequency will be more, and the listener, when it is moving away from the source, apparent frequency will be less. So correct answer is option 1. Next is question number 24. When a point source of monochromatic light is at a distance of 0.2 meter from the photoelectric cell, the cutoff voltage and the saturation current are 0.6 volt and 18 milliampere respectively. If the same source is placed at 0.6 meter away from the photoelectric cell, then stopping potential will not change. Over here it will be the same value, that is 0.6 0.6 volt because it is independent of the intensity. By changing the distance, the intensity will change, right? Intensity is inversely proportional to R square, but stopping potential will not change, and saturation current will change according to the intensity. So saturation current will be 18 milliampere divided by 9 because we are increasing the value of R by 3. So this will be 2 milliampere. So correct answer is option 2. Next is question number 25. From the given figure describing photoelectric effect, which of the following can be inferred correctly? So we know that H mu is equals to H mu naught plus EVS, right? So you can write EVS as H mu minus H mu naught, and VS is H upon E mu minus H mu naught divided by E, right? So you can see that over here, the maximum kinetic energy for both the metals depend linearly on the frequency, right? So this is for maximum kinetic energy and it is directly proportional to Vs. So it depends linearly. This is the equation of straight line. So this depends linearly on the frequency. So correct answer is option 2. Next is question number 26. Light of wavelength 4000 angstrom falls on a photosensitive metal and give a negative 2 volt potential stops the emitted electron. The work function of the metal is approximately. So over here, energy will be 12375 divided by 4000. So it will be approximately 3.09 electron volt, right? And stopping potential is 2 volts. So over here, kinetic energy maximum will be 2 electron volt, right? So work function will be E minus K max, which is equal to 3.09 minus 2. So it is approximately 1.1 electron volts, which is option 1. Question number 27. Which of the following variation between the applied potential difference and photoelectric current at two different intensities of light, I1 greater than I2 for the same frequency of incident light is? So V naught will be independent of intensity, so it will be same for I1 and I2, but I is directly proportional to intensity. So over here, I1 will be greater than I2, right? So correct answer will be option 2. Question number 28. A brass rod of length 50 centimeter and diameter 3 centimeter is joined to a steel rod of the same length and diameter, which is what is the change in length of the combined rod at 250 degrees Celsius if the original lengths are at 40 degrees Celsius. So for brass, delta L1 will be L1 alpha 1 delta T, which is 50 centimeter into alpha 1 is 2.0 into 10 power minus 5, and delta T is 250 minus 40, that is 210. Delta L2 will be L2 alpha 2 delta T, which is change in length of the steel rod, which is 50 centimeter. Alpha 2 is 1.2 into 10 power minus 5 into delta T is 210. So change in length will be delta L1 plus delta L2. So after calculating this value, you get the change in length as 0.34 centimeter, which is option 2. Question number 29. A beaker is filled with water at 4 degrees Celsius. At one time, the temperature is increased by a few degrees Celsius above and 4 degrees Celsius, and another time it is decreased by few degrees Celsius below 4 degrees Celsius. One shall observe that. So we know that at 4 degrees Celsius, the density of the water is maximum. When you increase or decrease the temperature from 4 degrees Celsius, the density decreases and volume increases, right? So in both the cases, water will overflow in both the cases. So correct answer is option 4. Question number 30. We have two identical containers, that means same volume V0 are joined by small pipe initially contain the same gas at pressure P0 and absolute temperature T0. One container is now maintained at the same temperature while the other is heated to 2T0. The common pressure of the gas will be. So initial number of moles will be final number of moles. So initial number of moles will be according to PV is equals to nRT. N will be PV upon RT. So for the first container, it is P0 V0 upon RT0. For the second container, it is P0 V0 upon RT0. Let's say common pressure is P, so it is equal to final number of moles in both the containers, that is P V naught upon R T naught plus P V naught upon R 2 T naught. Right. So after solving this one, you'll get the value of P as 4 upon 3 P naught, which is option 2. Question number 31. When the temperature of a gas filled in a closed vessel is increased by 1 degree Celsius, its pressure increases by 0.4%. The initial temperature of the gas was. So, it is a closed vessel. That means P1 upon T1 is equals to P2 upon T2. So, T1 can be written as P1 upon P2 into T2. Right. So, this will be P1 is let's say P and P2 is P plus 0.4 divided by 100 into P into T2 is T1 plus 1 because we are increasing by 1. So after solving this equation, you'll get the value of T1 over here as 250 Kelvin, which is option 3. Question number 32. A light string passing over a smooth light pulley connects two blocks of mass m1 and m2. If the acceleration of the system is g by 8, then the ratio of the masses is. So acceleration is g by 8, which is m2 minus m1g divided by m1 plus m2. Okay? G cancel. So we have 8m1 plus 8m2. Just a second. We have m1 plus m2. m1 plus m2 as 8m2 minus 8m1. So after solving this one, you'll get the ratio of m1 to m2 as 7 upon 9, 9 upon 7 over here, right? So correct answer will be 9:7, which is option 1. Next is question number 33. A machine gun fires a steady stream of bullets at the rate of n per minute. So we are firing n bullets in 60 seconds into a stationary target in which the bullets get embedded. If each bullet has a mass m and arrives at the target with the velocity v, the average force on the target is. So it is delta p upon t, right? So over here, change in momentum of n bullets will be nmv divided by time taken is 60. So nmv upon 60 is the force, which is option 3. Question number 34. The kinetic energy of molecules of a gas per liter of its volume is found to be 300 joules, right? Then its pressure will be. So over here, if you want to write the value of pressure in terms of kinetic energy, it is very simple that pressure is 2 upon 3E, right? So this is nothing but pressure is equals to 2 upon 3E, right? And we have a kinetic energy of 1 liter as 300 joules. So E will be 300 divided by 10 power minus 3, right? So over here, pressure will be 2 by 3 into 300 divided by 10 power minus 3, which is 2 into 10 power 5 Newton per meter square, which is option 4. Question number 35. At what temperature will oxygen molecule have the same root mean square speed as hydrogen molecule at 200 Kelvin? So, Vrms is given as under root 3 kT upon m. So, for oxygen and hydrogen, this value is same. That means under root 3 kT of oxygen divided by mass of oxygen is equals to under root 3 kT of hydrogen divided by m of hydrogen. After squaring, you can write TO upon MO is equals to TH upon MH. So TO will be MO, which is 32 divided by MH is 2 into TH is 200. So this is 3200 Kelvin. If you subtract 273, you'll get the value in degrees Celsius, which is 2927 degrees Celsius. Question number 36. 4 point charges Q1 and Q2 are kept at point X and 0 and 6 respectively. Electric potential will be 0 at the points. So we have 2 microcoulomb over here, minus 1 microcoulomb over here. And let's say this is position X1 and this is position X2 at which the value of potential is 0. So for the first case, this complete is 6. This is X1. So this is 6 minus X1. Right, so for the first case, electric potential should be 0 at x1. So it is k q upon x1 minus k into 1 upon 6 minus x1 should be 0. Right, so over here, 2 times 6 minus x1 minus x1 should be 0, right? So 12 minus 2x1 minus x1 is equal to 0. So x1 will be 4 meter, right? Next is 4 units. We can write it as 4 units. Next is at x2. So from 2 microcoulomb, the separation is 6 plus x2 or just x2. We are taking it from origin. So this is just x2 and this will be 6 minus x2. x2 minus 6. Total is x2. We need to subtract 6 from here, right? So this will be, this much distance will be x2 minus 6. So at x2 position, let's put the total potential value is equals to 0. So it is k q upon x2 plus k minus 1 upon x2 minus 6 is equals to 0. So after solving this one, you'll get the value of x2 as 12 units, right? So at x is equals to 4 and 12, we'll get total electric potential 0. Question number 37. In the figure, a potential of plus 1200 volt is given to point A and point B is Earth. What is the potential at the point B? So because of earthing, its potential is taken as 0. Right. Now 4 and 2 are in parallel. So its equivalent will be 4 plus 2, 6 microfarad. So basically 3 and 6 microfarad are in series across 1200 volt potential difference. Right. So we know that Q is equals to CV. Charge will be same, only potential difference will be different and V will be Q upon C. So V1 upon V2 will be C2 upon C1. Right. So this 1200 ka potential difference will be divided across 3 and 6 in the inverse ratio of their capacitances. So V1 upon V2 will be C2 upon C1, which is 6 upon 3, that is 2. Matlab V1 is equals to 2V2. Fine. So if it is V2, then 2V2 will be V1. So total 3V2 is equals to 1200. So V2 will be 400 volt. And V2 is nothing but potential difference of point P and 0. So that is Vp, which is 400 volt. So correct answer is option 3. Next is question number 38. We have current of 5 ampere which is passing through a metallic wire of cross section this. If the density of charge carriers of the wire is this much, the drift velocity of the electrons will be. So we know that I is equals to NEA VD. So VD will be I upon NEA. I is phi, N is phi into 10 power 26 into E is 1.6 into 10 power minus 19 into A is 4 into 10 power minus 6. So after solving this one, you'll get the value of drift velocity as 1.56 into 10 power minus 2 meter per second, which is option 2. Question number 39. Resistances in the two caps of the meter bridge are 10 and 30 ohm respectively. If the resistances are interchanged, the balance point shift by. So let's say initial balance point is at L1 and final is at L2. So we have R1 upon R2, that is 10 upon 30 is equals to L1 upon 100 minus L1. So 100 minus L1 will be 3L1. So L1 will be 25 centimeter. Now we are interchanging the resistances over here. So 30 upon 10 will become L2 upon 100 minus L2. So it will give you L2 is 75 centimeter. So shifting will be L2 minus L1, which is 75 minus 25, which is 50 centimeter. So correct answer is option 4. Next is question number 40. The value of horizontal component of Earth's magnetic field is 0.35 into 10 power minus 4 Tesla. The angle of dip is given as 60 degree. The value of vertical component of Earth's magnetic field is about. So BV is BH into tan theta. So this is 0.35 into 10 power minus 4 into tan 60 degree, which is root 3. So after solving this one, you'll get the value as option 2. Question number 41. A particle of mass m carrying a charge q enter normally into a uniform magnetic field induction B. The time taken by the particle to traverse 90 degree arc is. So particle will perform circular motion. This will be the 90 degree arc. So we need to find the time taken by the particle to reach from point A to B. Right. So total time taken is 2 pi m upon qb, and this is just 1/4 of the path. So it will be 1 by 4 times the total time taken, which is pi m upon 2 qb, which is option 3. Question number 42. What is the magnetic field induction at point O? So at a point O, because of this wire, there will be no induction. This is semicircle. So because of that, it is mu naught I upon 4r, and it is out of the plane, right? Plus, we have this semi-infinite wire. So at a distance r, the value of magnetic field induction is mu naught I upon 4 pi r, and it will be again out of the plane. So summation of this two will give you what? Net magnetic field at point O, which is option 3. Question number 43. The length of the string is 10 meter and mass is 1.25 kilogram and tension is 50 Newton. If a transverse pulse is created at one end of the string, how long does it take to reach the other end? So velocity is under root t upon mu of this pulse, right? Under root 2 t is 50 divided by mu, which is mass upon length, it is 1.25 divided by 10. So this will be the value of velocity. Now over here time will be length upon velocity. So length is 10 divided by velocity is under root of 500 divided by 1.25. Okay. So this will give you approximately exactly 0.5 second, which is option 1. Question number 44. We have two sources, A and B are sounding notes of frequency 680 Hz. A listener, that means observer, is moving from A to B and speed of sound is 340 meter per second. So what should be the velocity of the observer so that he hears 10 beats per second? Okay. So when the listener is moving away from A, the apparent frequency will be less than actual frequency, which is equal to 680 into V minus VO divided by V. And if it is moving towards V, apparent frequency will be more than actual frequency, which is equal to 680 into V plus VO divided by V. Now the difference in frequency will give you beat frequency, that is equals to 680 into V plus VO divided by V minus 680 into V minus VO divided by V, and that should be 10, right? So after solving this one, you can get the value of velocity VO as 2.5 meter per second, which is option 2. Question number 45. How many photons of a radiation of wavelength lambda must fall per second on a blackened plate in order to produce a force of 6.62 into 10 power minus 5 Newton? Right, so over here force will be NH divided by lambda. So N will be F lambda divided by H. Force is 6.62 into 10 power minus 5. Lambda is 5 into 10 power minus 7 divided by H is 6.62 into 10 power minus 34. Right, so this will cancel this. So we have 5 into 10 power, this is 12, so this is 22, right? 5 into 10 power 22 is the answer. Question number 46. If the wavelength of a light in an experiment on photoelectric effect is doubled, keeping the intensity constant, then the photoelectron may or may not be emitted. Yeah, that is true, because we are changing the wavelength of the light over here, right? And as energy is hc upon lambda, so by increasing the wavelength, energy might decrease, and so photoelectrons may or may not be emitted, right? So this option is true. Next is the stopping potential decreases if electrons are emitted. Okay, so over here electrons which are emitted will have the less kinetic energy. Fine, because by increasing the wavelength, the energy of the total energy is decreasing, right? So maximum kinetic energy is directly proportional to stopping potential, right? So because of the decrease in kinetic energy, stopping potential decreases. So this is also true. Okay, so in this case option A and B are true, so correct answer is option 1. Next is question number 47. We have in a photoelectric experiment with light of wavelength lambda, the fastest electron has speed v. If the exciting wavelength is changed to 3 lambda by 4, the speed of the fastest emitted electron will be. So we know that half mv square is equals to hc by lambda minus 5. For the second case, let's say it is half mv dash square is equals to Hc upon 3 lambda by 4 minus 5. Right, so clearly you can see that V dash will be greater than under root of 4 by 3 into V. Right, so correct answer will be option 4. Fine. Next is question number 48. In a photoelectric experiment, when energy of photon incident radiation is 6.5 electron volt, stopping potential is found as 3 volt. In the same experiment setup, what will be the wavelength of the incident radiation if the stopping potential is 2 volt? So over here, work function will be 6.5 minus 3, that is 3.3 electron volt. In the second one, if stopping potential is 2, then energy will be 3.5 electron volt plus 2 electron volt, which is 5.5 electron volt, and this is equal to Hc upon lambda, right, which is 12420 divided by lambda, right. So over here lambda will be 12420 divided by 5.5 angstrom. You'll get the answer in angstrom, which is equal to 2258 angstrom, which is option 1. Okay. Next is question number 49. A mercury thermometer contains 2 cc of Hg at 0 degrees Celsius. Distance between 0 degree and 100 degree marks are on the stem are 35 centimeter and diameter is 0.02 centimeter. That means radius is 0.01 centimeter. Ya of liquid is. So in this case, we know that gamma is equals to delta V upon V naught delta T. Okay. Delta V is pi r square into h divided by V naught into delta T. Fine. So over here, after putting the values of everything, you'll get the value of Y, that is equals to option 1, 0.00055 per degree Celsius, 0.000055 per degree Celsius. I hope this is clear. Next is question number 50. Gas at pressure P naught is contained as a vessel. If the masses of all the molecules are halved and their speeds are doubled, the resulting pressure will be equal to. So initially, the pressure P naught is 1 by 3 mn upon V RMS square. Okay. Now, if the masses are 1 by 2 and speeds are doubled, then P will be 1 by 3 m by 2 n upon V into 2V RMS whole square, which is equals to 2 times 1 by 3 mn upon V into V RMS square. Okay. So you can see that P is equals to 2P naught, right? So over here, the final answer will be option 2. So that is it for today's session, guys. I'll see you again with the next paper discussion. All the best, everyone. Take care. Bye.